Welcome back to this Python Basics tutorial. In the first section, we went over most of the built-in types and built-in constants. In this section, we are going to go over all the multiple data types like lists, dictionaries, tuples, list comprehensions, and go over some of the basic control flow statements. Like with anything in life, in the beginning it's a bit boring and dry, but it gets so much more interesting with time. But before we get to build some awesome projects, we need to continue learning the basics. So let's not lose any more time and let's get into it. Let's continue our great journey with the basic built-in types and data types. So Python provides us certain data types that are built into the interpreter. This means that the Python compiler is going to be able to pick those values, to pick those types and make sense out of it. So the basic types are going to be numerics, sequences, mappings, classes, instances, and exceptions. We actually, funnily enough, went through most of them in the last section, but we are going to go with much more detail through them now. Let's start with the true value testing. As we have already mentioned, we have the constants true and false, which are built-in types. Those are actually subtypes of integers. So the Boolean operators can be and, or not. We can show an example using an if statement. So for example, if 1 is equal to 2, of course it's not, but we can also specify is 1 equal to 1. We're going to print something. So this is not the best of all examples, but it is going to get the point across. Now if we print this, so our file is 4 built-in types, data types, we're going to see true because 1 is equal to 1. If we said, for example, and, this is not going to hold because one of our requirements is not met. The next are going to be comparisons. We can compare values using smaller, smaller equal, larger, larger equal, equal, not equal, and is object identity. And this is going to be maybe the hardest of them all. Is object identity is not the same as equal, because if two objects have the same value, is for reference equality, and if two references point to the same object, then we can say that this is the object identity. So just remember, is means that we are talking about the same physical object, and equal means just that the values are equal. Now let's go to the numeric types. Regarding the numeric types, we have integers, floats, and complex for complex numbers. I think you're most probably familiar with all of them. If we want to print, for example, a 1, this is going to be an integer. If we point 1.0, this is going to be a float. And then we can also add complex types. We can add a complex type by really calling its function complex. So the real part is going to be 3 and the imaginary part 2. And as you see the result here, this is also a different way how we can define it. We can define it like 3 plus 2j. So this j is going to be picked up by the interpreter and it is going to give us the same result. Now let's go over iterators. Python supports a concept of iteration over containers. One method needs to be defined for container objects to provide iterable support. This is going to be the container iter method. If a container has this method provided, then we can iterate over the values. So if we now create a tuple, let's call it planets. Planets are going to be Earth, my favorite one so far, Mars, and Saturn. If we now want to loop over those values, we can say for x in planets, this is going to return us an iterable, and we can print x. So this means that tuples need to implement the iter method. And as you can see, we can loop over them, no problem. Now we come to sequences. We have talked about sequences quite a lot, and this is an example of them. So sequences are, as the same word says, a sequence of different items. The main types include lists, tuples, and range. They can be splitted into immutable and mutable sequences. So immutable meaning we can't change them, and mutable meaning we can change them. So lists are mutable sequences, and tuples and ranges are immutable sequences. Let's go over the basic operations those support. So now let's create a new planet. So for example, we are going to create a new tuple, and it is going to include only Earth. And now we're going to create a different planet, planet 2, and we're going to name it Mars. And let's print this and see if p2 in planet. Let's run this, and as you can see, it is false because Mars is not in the tuple Earth. This represents a list of all the operations we can do on sequence types, the immutable and mutable operations. So the operations on immutable and mutable types. Since we said that mutable types are lists and immutable tuples and ranges, the first list here applies to tuples and range, and the second one to lists. So let's go over them. We already went over the first two ones. So to continue, we can concatenate, in example, tuples. We can multiply them with each other, and we can slice them. Slicing is a very important concept. We're going to create a few examples of this. Let's create a new tuple and call it S. And it is again going to contain the planets, Mars, and Saturn. So this is our tuple, and let's say we want to slice it from I to J. So let's print this part, and we're going to say we want it from the first index to the second, since we're counting from 0. Let's run this, and we're going to see only Mars. If we would like to see the entire tuple, we would need to slice it from 0 to 3. Let's run it, and this is our full tuple. Let's add a few more values, and let's say exoplanet. Now let's say that we also want to add a step. We are going to go from 0 to 4, and we are going to step only through the every second occurrence of our items. And as you can see, we went through Earth, we skipped Mars, we went through Saturn, and we skipped the exoplanet. So this is the step here. Now we can of course print the length, which we have already done in the previous part, but let's do it again. So the length is 4, we can find the minimum and the maximum value. We can also find the index of a certain item. So let's say the index of, for example, Earth, which should be 0. And we can also search for the first occurrence of an index. And we can also count the number of occurrences. And Earth only occurs once. So those are basically all the immutable operations you can do on sequence types. But bear in mind that with different libraries, you're in most cases going to use the functions from the libraries and not just the plain Python stuff. But this is also going to get us very far. Now let's go over the mutable stuff. Of course, the same stuff applies again. This time we can just change things. Let's create a list now. In order to create a list, we can just type out list, or we can use the braces and create it like this. Both are going to be very similar with similar operations. The difference in list supporting inhomogeneous types and the array supporting only the same types. So since we are going to use only numbers, we are going to use the arrows. Now let's replace a value at index 0 with, let's say, something visible, 99. And now let's print this. If we want to print this, we successfully replaced the position, the index 0 with the value 99. Now let's say we wanted to replace more indexes, and let's say from 0 to 2. Now we need to specify with what we want to replace all of those indexes, and let's say we want to replace them with 99. Let's run this, and as you can see, the first two indexes are now replaced with 99. We can of course use a step as we showed in the immutable section. We can also assign a different array to the same array. We can also delete certain values. So let's say that we want to delete the indexes 2 to 3. I forgot the S here. And let's print this again. And now we lost the index 3. Sorry, the index 2. We can now also append values. So S append 88. This is going to add the 88 as the last value. We can clear it and we can copy it. The important part to remember with copying is that it creates a shallow copy. So it uses still the same references. It is not going to physically copy the memory allocation of the object. And as you can see, a copy is the same as a full slice, starting from index 0 and ending at the last index. We can also insert at a specific index. So let's say we want to insert at index 3 a value and not append it at the end. We can pop a value, which is either going to pop the last value or pop a value at a specific index. We can also remove the first item where the array is equal to X. And we can also reverse all the items in the array. Let's go once more over the items. In the mutable category, we have lists. In the immutable category, we have tuples and ranges. As we said, lists are mutable sequences typically used to store collections of homogeneous items, where the precise degree of similarity will vary by application. And besides that, the standard operations, they also implement the additional sort method. Tuples are immutable sequences typically used to store collections of heterogeneous data, and ranges are also immutable sequences of numbers, and they are commonly used for looping. And we already had multiple examples with them. You can either create them by calling their function, for example, lists, tuples, and range. And those are not tuples, but tuple. And for lists, we can also create them using an array, which is going to be an array slightly different from a list. We can create a tuple by just calling the braces here, which is going to return exactly the same tuple. And for a range, we have to call the range function. Now let's also take a look at text sequences, namely strings. Textual data in Python is handled with string objects. Strings are immutable sequences of Unicode encoded characters. In most cases, this is UTF-8. There are three ways to write strings in Python: single quotes, double quotes, and triple quotes. So let's create an example. A is going to be single encoded, A is A. B is going to be double quotes. Let's say B is B, but not A. And our third option is going to be triple quoted, which is going to be triple quotes like this. C is C. And now the main difference between single and double quoted is how we can embed things. So in the single quoted option, we can embed double quotes like this. And in the double quoted string, we can embed single quotes like this, as an example. The biggest difference with the triple quoted strings is that they can span across multiple lines, and all associated white spaces will be included in the string literal. So if we, for example, want to have more text and we want to define the spaces and indentations and everything, this is going to keep it. If we now want to print C and we want to run Python our text folder, as you can see, it is going to keep its form. And if we run, for example, B, it is going to keep the single quotes. There are, of course, some methods that we can use on our strings. We can, for example, count the number of occurrences. We can try to find the index at which we find a certain character. So, for example, let's say that we want to find in the string B, we want to find the character I, for example. And let's say we print this. And as you can see, this is index 0, 1, 2. So we get the index 2. We can also count the number of occurrences. We only have one I. We can also capitalize letters. And we can, of course, check if a string is actually a digit. So this is going to return true if all characters in the strings are digits and there is at least one character. So let's create a D, which is going to be again a string and include only the characters 1, 2, 3. And we are going to see if D is a string. Sorry, is digit. Let's run this. And true. If we add character A, it is going to return false. Another very common sequence type, mostly overlooked, are binary sequence types. So in most cases, you're not going to directly work with bytes, but it is good to know that they exist and what you can use them for. So as binary sequence types, you have bytes, byte array, and memory view. So a byte is a unit of digital information that mostly consists of 8 bits. The core built-in types for manipulating binary data are bytes and byte arrays, and we're also going to scratch memory views. Interesting about memory view is that it uses the buffer protocol to access the memory of other binary objects without actually needing to make a copy, which can be very useful for loading large amounts of data. Let's try to create a byte. We can do that simply by, let's say we want to create our byte by using the character B and encoding it again in single, double or triple quotes. And we can say that this is our byte. It is also important to mention that we can only use ASCII characters as literals. It is also interesting to point out that we can convert between different bases. So let's say that we want to convert from the hexadecimal base. Let's say that we want to print. So we can access the bytes object. We can access the function from hex, so from hexadecimal. And let's use some numbers here. F1, F2. And let's run this. And as you can see, we got it converted into bytes. And we can of course do the same in reverse. So let's run this again and copy the value. And now let's say that we want to convert it to hex. For that, we just call the hex function and let's run this again. And now we have the hexadecimal numbers we had earlier. So far we worked with bytes, which are immutable. We also have byte arrays, which are the mutable counterpart to byte objects. They support similar operations, as we also saw with other data types that have different operations for their mutable and immutable counterparts. Let's now take a deeper look into memory views. So memory view objects allow Python code to access the internal data of an object that supports the buffer protocol without copying. Built-in objects that support the memory view buffer protocol are bytes and byte arrays. So the memory view function, memory view, allows direct read and write access to an object's byte-oriented data without actually needing to copy it first, which is very cool. Let's say we want to create a memory view out of a byte, let's say A, B, C, D, and we say this is equal to M. And then let's say we want to print this. Let's print M at position 1, for example. And we get 98. Now, based on the underlying object, if the object is writable, we have more options to it. So we can, for example, slice the object and assign different values to it. Bytes are immutable and byte arrays are mutable. So if we use the byte array, we would be able to change and write the underlying object. Let's check if the object is writable by calling its attribute read-only. If we run this now, we're going to see it's true. So it's read-only, we can't write to it. Let's say we wanted to create a byte array now. What we would do is call byte array. We still have our byte inside. Byte array, not really good with spelling today. Okay, and let's run this again. And as you can see, false. One-dimensional memory views can also be indexed with an integer. So let's import an array. And we can delete this code here. In this case, I am going for an array, but you can of course use a list. The difference is, as we have mentioned at the beginning, that with arrays, you're going to have homogeneous types, and with lists, you can have everything in it. So there is a different memory consumption depending on your application. So if you don't need lists, don't use them. Let's create an array. A is equal to array, and we want to initiate a new array. And let's define some values. Now, let's say that M is equal to memory view of our array A. And now let's say we want to print M at index 0. Let's run this code again. And as you can see, we were able to utilize this array with our memory view. Now let's continue to set types, which are set and frozen set. Let's first take a look at a set. So the definition of a set is that it is an object of an unordered collection of distinct hashable objects. So distinct meaning unique, and hashable objects meaning that a hash function can be applied to them. So some common use cases include membership testing, removal of duplicates from a sequence, computing mathematical operations like union, intersection, difference. So as you can see, it is very useful for doing math stuff. As I already mentioned, there are two different set types. One is mutable and one is immutable. Set is a mutable type and frozen set is the immutable counterpart. Let's create an example set. So let's say our set is equal to our favorite planets, Earth, Mars, and Saturn. And as you can see, we initialize the set with the curly brackets. We could have, of course, called the function set and done the same. We can do some of our favorite operations on them. Since sets are mutable, we can add values, we can remove them, and we can pop values similar to our other sequence types. So we could do something like set add, apple. Let's print the values, print set, and let's run it. And as you can see, our set got the new value. And as you can see, the apple didn't get added at the last spot as we are used, but it is here in the middle. As we have already mentioned, a set is an unordered collection of hashable objects. Let's not go over the same operations again with sets as we have done this with tuples. You can, of course, check this always on the official Python documentation. But there are, of course, additional stuff you can do with sets. As we have said, it's useful for maths. You can check if one set is included in the other. You can check the length. You can also check if two sets are joined. You can, of course, check if they are a union, and so on. And you, of course, can also create a copy of a set. And again, remember that a copy is only a shallow copy, which means only the references and not the full copy of the child objects. Now let's go over to mapping types, namely dictionaries. A mapping object maps hashable values to arbitrary objects. So mappings are mutable objects, and there is currently only one standard mapping type, which is the dictionary. You of course have a solitude of different options, but for that you are going to need to install different libraries. And we are of course going to go into much more depths of that when going through those libraries. A dictionary's keys are almost arbitrary values, so values that are not hashable. So this means values containing lists, dictionaries, or other mutable types may not be used as keys. Let's create an example dictionary, so let's call it D, and we again initialize it with curly braces, but this time we have the difference that we have key value pairs. So let's say that our key is called key 1 and our value 1, and we can create a key 2 with a value that is, for example, going to be a number. We can also create a dictionary using the constructor, so calling the function dict, and we can specify our keys. So key 1 is going to be equal to value 1, and key 2 is equal to 1, 2, 3. And we should call this differently. Let's call this D2. Let's print our dictionary D, and those are exactly the values we have specified. We can also do something really cool, list comprehensions. We are going to go deeper into that later on, but let's try it out. Let's print a dictionary. The dictionary is empty. Now let's fill it up with stuff. So in order to fill it up, we are going to use a list comprehension. We are going to pass a value, and we are going to do something with that value. So we are going to, let's say, create the x to the power of 2. We are going to do that for x in a certain list of items to have multiple items in our dictionary. In order to create a fast list, let's use the range function. And let's say we want to have 10 values. Let's try to print this out. And as you can see, we got a dictionary filled out with our list comprehension. So we have a value, which is the key, and the other value is its value squared. You can of course use other standard operations like list, length. You can access a value. So let's say that we want to access the key 1 on the dictionary D2. Let's run this, and as you can see, we have the value 1 here. Other standard operation types include copy, clear, the in, so we can see if a key is in a value. We can pop an item, reverse values, and mostly all the same operations we have experienced so far. So it doesn't make sense to go through all of them. Again, refer to the Python library. And when we are going to create our project, we are going to go more deeply into real life usages of dictionaries and different sequence types. So we're almost over with the basic stuff. Let's now continue to context managers, which are also a pretty useful feature in Python. This code here is going to open a new file, and it is going to write something into it and close the file. Let's run this function, and poof, we have our text file with new text written into it. If anything goes wrong, we want to open a file that doesn't exist, for example, we would have an exception. That exception would be caught in the finally block here. So the exception could occur in the try block, and it would be called in the finally block. And again, we're also going to go into error handling much more deeper, where you can define your own exceptions, your own classes, and so on. So the thing here is that we need to think about what we are going to do in such an exception. We need to close the file stream. We could have a memory leak or many more different problems if we don't handle our exceptions correctly. This is what context managers do. So with a context manager, using with, I should get this indentation right. Using with, we can use our function open. We are going to call this hello text. We are also going to have the mode in write mode as file. And now we can again do the same stuff we would have done in the try block. You're going to write new text 2. And if something goes wrong here, this will be caught and it will be closed. So the file stream will be closed within the with context manager. So it is going to take care of handling exceptions for us. The important part is that whatever we are working with, so in this case our file manager, it is important that it has the method enter and exit implemented. If it doesn't, you can of course implement it on your own in your objects, but those methods are going to be called within the context manager and they are going to handle your initialization and closing of whatever function you are running. So now we are really almost over. Two more things that you could consider are special attributes and the limitations of integers. So special attributes include, as the name says, attributes that are included in certain objects. So every object is going to have the attribute ticked, which is going to do the same as you can remember with our dir function. It is going to give us information about the object. For instances, if we have an instance of an object, which we are going to cover in the classes section, we can access its class. We can also access its subclass, and there are a few others, special attributes and methods you can access depending on the instance and object you are going with. One last thing when it comes to data types and the basics is the integer length limitation, which you should consider in Python. Python has a global limit for converting between integer and string, mostly to use as a countermeasure against denial of service attacks. Since converting large numbers into strings can cause a lot of CPU usage, it could cause your server to crash. If you, for example, want to create an integer, as you remember, we had also the isDigit function, so we can check if this is actually a digit, and since it only includes digits, it is. And we can multiply this with a number, let's say 500,000. And now let's say we want to print the value. As you can see, it is taking our hardware quite some time to figure this out. It is also important to mention that this limit applies only to computationally intensive conversions, which are between integers and strings with a default base of 10. This does not apply to other bases as, for example, 16 or 2. You can expect the current setup of your system by using the sys library, so system. Now it's again the perfect time to take a break, but before we do that, let's quickly recap what we have done so far. So we went over data types, we went a little bit over output, we went over lists, dictionaries and arrays, we went also a little bit over list comprehensions and functions, and a little bit with libraries. We also touched the topic of errors and exceptions a little bit. We are now going to continue with control flow statements, list comprehensions, and go deeper into the topics we have touched so far, like functions, libraries, errors, and exceptions. I hope you liked the content so far and the pace was right. If you would like to see improvements or changes, please leave a comment down below or contact me on my email. If you liked it so far and want to continue on, please like and subscribe, and I'll see you in the next one.